in contrast to what you might think, clocks and time itself doesn't tick at the same rate at every different part of the universe. Imagine some big hands on our trampoline applying tension to the edges. So I want you to be able to trust the Bible to be true. A light year is the distance that light travels in 1 year at today's rate, and that's about 6 trillion miles. And we do see objects out there that are billions of light years away.
You are, just for folks who are joining us, in 1959 you were one of 40 winners of the Westinghouse National Science Talent Search, and you got your Bachelor of Science from Duke in 1963 in physics, and then you went to LSU, and in 1972 LSU gave you a PhD for your research. Tell us about that research. Cosmic rays.
It's cosmic rays slamming into nuclei, atoms in the atmosphere, blowing them apart, and we pick up the pieces and try to figure out what happened.
It sounds fascinating. You got your PhD for picking up the pieces.
Yes.
Okay, very good. And then for 6 years you worked for General Electric in their high voltage laboratory. You worked from 1979 through 2001 at the Sandia National Laboratories. And there you just studied little things like nuclear physics, geophysics, pulse-powered research, theoretical atomic and nuclear physics. You're the holder of 3S patents. You won 2 awards while you were working there for excellence in contributions to the light ion fusion target theory. Then you left all of that to work in the field of creation science research.
I'm very honored to speak with Russ Humphreys. He has a degree in physics. And what else can you tell us about yourself, Russ?
Well, I was born in a non-Christian family, and so I was raised essentially in evolution and the Big Bang, as much of it as existed back then, and believed in the billions of years until I was age 27 when I accepted Christ as my Savior.
Okay.
I went on trying to be an evolutionist for about a year.
So you were an evolutionist. I mean, you weren't just an unbeliever, but you were...
Actually, I was an atheist,
so you were. Okay.
Somewhat rug-chewing variety.
Meaning you were
pretty
very
vehement.
aggressive?
Yeah.
Yes.
And at least arrogant. I accepted Christ as my Savior. About a year after that, I became a creationist because I was starting to get convinced by some creationist evidence.
I see.
A book by Henry Morris and some other sources. So I got saved and then became a creationist because of the evidence.
Right. And sometimes with some people, it's the other way around.
Yes,
Yeah.
I know some people like that. Jesus Christ implies that the world is young. In the famous passage in Mark 10, and also it's in Matthew, and I believe it's elsewhere too, he's talking about marriage and divorce. And he starts his discourse by saying, "But from the beginning of the creation, God made them male and female," Mark 10:6. So beginning, that's the first verse of Genesis. In the beginning, God created the heavens and the earth. That's the first beginning of the first day. And then God made them male and female is a quote from the 6th day of creation. So Jesus is calling all of that the beginning. And he's saying mankind has been around from the very beginning. Now, that's not what evolution says. The Big Bang Theory says. And mankind, in his present form, they think, did not come along until about 200,000 years ago, which is a tiny fraction of 14 billion years. So the evolutionists would not say what Jesus said, from the beginning of the creation, or from the beginning of the universe, God made them male and female. So there's a big difference. There's a close-up look at the 6th day. There's no room for long ages.
You're very much into Starlight and this whole topic of how is it that stars could appear to Adam and Eve approximately 6,000 years ago.
Yeah.
Personally, I find that subject to be very fascinating because I think that naturally from a creationist point of view, that does seem rather awkward. It seems counterintuitive that stars billions of light years away could appear to Adam and Eve, or even could, you know, if we're in a 6,000-year universe, could appear to us.
Or if you think about it, the nearest star is 4 light years away. So for Adam and Eve to be able to even see the nearest star,
even the nearest star, wow,
by a few days after they were created,
right,
needs to be explained.
Right. So you've developed a cosmology, biblically sound cosmology that every creationist in the entire world agrees with, right?
No.
No, but it is a sound, I believe, it's a sound cosmology that makes sense. And you have stated, I think, numerous times in the video Starlight in Time, and maybe also in your book, that you look at the scriptures, and you looked at the scriptures to help you to develop the cosmology, and you admit that there may be some tweaks that need to still happen, or somebody else may have a better cosmology,
yes,
but in the end...
I know several creationists that have some good cosmologies, and,
right,
and I like one of those a lot, actually.
Okay.
Several other creationists
right,
using general relativity also,
right,
as part of their
But this is a way to say that there is a legitimate, realistic way to account for how you would get stars billions of light years away to appear to us as well as Adam and Eve, and do it in a scientific framework.
Right, and like I was saying, there's more than one option for the creationists to choose from now, and they're good options.
Good.
And not just mine. So.
Good. All right, so we've made that very clear.
One hint is that there are waters, it says, at the edge of the universe, and there's a scripture for that. Praise him, sun, moon, and stars. Praise him, highest heavens, and the waters that are above the heavens.
And so with your scientific mind, you know, I'm just going to emphasize the praise him, but you're saying this is information that there is waters above the heavens.
Yes, and water, like all other material, has weight, has mass.
Now, I believe that because I believe the Word of God, but is there any scientific evidence that there's waters above the heavens?
There's indirect evidence, and we'll get to that.
Okay.
It makes some sense of some scientific mysteries. So I'm going to run a little animation here with this ball of waters that I'm picturing, that God made everything as water first, but we're going to run an expansion.
Okay.
So we have waters above the expanse. Here are the waters above. And there are waters below the expanse. And those waters, remember, started in the midst. That's also important.
And you're saying the water expands clear beyond the universe where we know it?
Yes, billions of light years, because it has to be big enough for the stars. Remember those waters that were above the heavens.
This isn't just an expanse for the atmosphere around the earth, but for the whole of the universe.
Yes, and Genesis says God placed the stars in the expanse, or in the firmament of the heavens. So, and he called this expanse heavens, or heaven. There's also a very interesting observation, is that the redshifts for galaxies, just ordinary galaxies that are within 300 million light years of us, they appear to cluster together in certain amounts. You know, there would be this much redshift for some galaxies, and then a little bit more redshift for other galaxies, but in between there aren't many galaxies that have the in-between amount of redshift. Now, this is something they only found out in the mid-1970s. And it was controversial for a while, but now astronomers who know about the problem, it's a problem to them. They know this, but other astronomers haven't kept up with it. But astronomers who've studied it, they have confirmed that the redshifts that we see are in regularly spaced groups. So this is the percentage redshift along the bottom here. And this is just one sample set of numbers. And this is number of galaxies they see at a given redshift. So here's a group that's at 0.024% redshift, and then another group at 0.048 redshift, 0.072, 0.096. And the guy who first discovered this is named William Tift, back in 1976 in Astrophysical Journal. Now, a lot of astronomers haven't kept up with the problem, but in 1997, two astronomers named Napier and Guthrie really confirmed this very well. They had a good technique, and they found that there were very distinct bunches. It's not just statistics. And in between the bunches, there's not many galaxies with these other redshifts.
Galaxies out there seem to be bunched.
Yes.
There's gaps between them, and then there's a bunch of them.
That's my explanation.
Okay.
The Big Bang people don't like that explanation, but we'll get to that.
That's your understanding of the
the
data.
redshifts from the galaxies are bunched.
Yes.
And what I'm proposing is that the redshifts amount to groupings of distance. So Hubble's law would change the groups of redshifts into groups of distances. Well, it suggests that the galaxies tend to form concentric shells around us, because this effect, this bunching, is the same in all directions. So we see...
Now that's going to become very important. It isn't...
Yeah.
It's uniform in all ways around us.
Right.
Okay.
Yeah. Now, a friend of mine, Dr. John Hartnett in Australia, studies cosmology, and he has shown that on an even larger scale than I'm talking about, we see actual pieces of concentric spheres of galaxies, vast spherical arcs, pieces of spheres pointed towards us.
Amazing.
At the center. So when I say we, I mean us, the Earth, our galaxy.
Our galaxy.
But it's evidence against the Big Bang theory. So having a center just does away with the Big Bang theory if there is one. But it's also evidence that the cosmos has a center. There was a relatively recent, about 2003, introduction by secular cosmologists of one similar to mine. Now, it didn't go anywhere. It was not very popular, but they considered that we were inside a black hole, that the whole universe was inside it, but we weren't at the center in their cosmology, but there was a center. I have a journal article that gives more details. Our galaxy is the center of the universe, quantized redshift show, for people who are interested in the technical details, and that's at creation.com. And you look up the Journal of Creation, and then you look up the August 2002 issue of it.
Very good. The redshift groupings that you talk about seem to be irrefutable evidence. How does the Big Bang, how do they explain it?
Well, basically they say there must be some other explanation.
Yeah.
and that's it.
But they don't know what that is.
No.
And they do have to acknowledge that the grouping seems to be there.
Yeah, the ones who are in the know do. There's a lot of not very well informed astronomers who think that the issue was settled a long time ago and that it was just statistical. But they hadn't kept up with abreast of
the more
events.
the evidence accumulates, the clearer the groupings become.
Yes. And they also, with John Hartnett's evidence, it's almost indistinguishable, undeniable that there's a large-scale grouping. I'm not saying the Earth is at the exact center, but I'm saying our galaxy is pretty much near the center of all this action. But the point is that then Einstein's theory of relativity says funny things start happening to time.
Science has discovered that physical processes and time can slow down when space is stretched, warped, or bent, which is actually quite easy to do. All it takes is a little matter. We can, in fact, detect the effect right here on Earth, but it requires very precise time measurement. The atomic clock is the most accurate chronometer ever invented.
2,988,000,000.
Its total error is just 1 microsecond, or just a millionth of a second per year.
2,988,000,000.
That's less than 1 part error out of 30 trillion. It would be like counting every blade of grass on 10,000 football fields and missing only one. Heads up!
2,900,000,000.
It turns out that 2 atomic clocks, one at Greenwich, England at sea level, and the other at Boulder, Colorado at 5,000 feet above sea level, will run at different rates. Time running at different rates right here on Earth may sound like science fiction, but it is pure science fact. Time runs at different rates because the mass of the Earth distorts space and produces a gravity well. England, being lower in elevation, is further down in the well compared to Colorado. Thus, time at Greenwich runs slower. To us, there is absolutely no sensation of time running at different rates because all physical processes are affected in precisely the same manner. The only way to verify a difference in time is to compare the same process running at two different depths in a gravity well. That is precisely what has been done with the atomic clocks. After a year, these clocks will measure an actual time differential of 5 microseconds.
And so this is a well-known phenomenon experimentally, and our GPS system depends on correcting for altitude.
Very interesting, yes.
And gravitational
so this is very
time
practical.
dilation.
This is not just theoretical.
No, this is
very
experimental physics that you really can't be argued with.
And this is also consistent with Einstein's theory of relativity?
It's not only consistent, it's a deep fundamental part of it. It's there in the theory, so we see it in the theory and we see it in experiment. So if the universe is only 6,000 years old, how could that light have traveled more than 6,000 light years away from the object that emitted it? A universe with a center would have clocks ticking slower near its center than at the edge. And if the universe were about 20 times smaller than it is now, clocks at the center would be dead stopped, while billions of years of events could be going on way out here. At the start of the fourth day of creation, the Earth was the only matter, the only stuff that was below the waters above the heavens. And that makes for an unusual gravity situation. And now I'm going to switch to an analogy, which I'll refer to throughout the whole program, which I think will help people understand. And the analogy is a good one. It reflects the math good, but it's a trampoline.
Okay.
You see this girl here?
I do.
You see down here what's happened to the trampoline that she's standing on?
It dents down. It's
her
pushed
weight
down by her
has
weight.
pushed down
Right.
that trampoline.
Okay.
Now I'm going to compare, and it's a good comparison, space to a fabric. Scripture talks about space as if it's a stuff, and I talk about this in my book, Starlight and Time. It's a material that we can't perceive. And mass, like the girl there, makes a dent in that stuff. So now let's go back to the waters above and think what they would do to our trampoline. The waters above are like a heavy ring sitting on the trampoline. So you see this heavy, imagine it made of lead or something. It flattens out the trampoline inside the ring, but it's made a dent in the whole trampoline. And that's just exactly what Newton's equations and Einstein's equations say happens with gravity.
Okay.
Now, those waters above are pretty massive, as it turns out. They make a deep dent. So here's a picture of the dent. And the vertical dimension, we can talk about it as being gravitational energy. That's how much energy it would take to haul a mass from the flat part all the way out, way above all the matter of the universe, well beyond the waters above the universe. That energy is a lot while you're down in the dent, but it's not much when you're way out here. They made a deep dent.
Wow.
Now, this leads to another thing. Let's take a cross-section of this trampoline now.
All right.
And I'll show it to you there. So here's distance out from where the Earth is here, out to way beyond the waters above. And here are the waters above. They're like that ring on the trampoline, making a deep dent. There's a depth to that dent below which there is no time. Nothing happens. All processes stop. It's dark. Light doesn't travel. Very dull place. And the Earth would be just above that dent. So if the dent were any deeper, time would stop for any part of the fabric. Because the fabric of space itself depends on this energy, this gravitational energy, and when it gets more than to greater than a certain amount, light cannot pass through it. Nothing can happen. Waves can't travel in it. We have another thing to think about. During the fourth day, God created the stars, and I'm going to, in this animation, picture them as God making them in a wave, a spherical wave traveling out from the earth. That's not essential, but just I'll run that animation again. Here, the green dot in the center here is the earth, and God is making the galaxies. Each of those is galaxies, all the way out to the waters above, empty space beyond the waters above. So that has an effect on our trampoline. The new star masses, the masses, that material would dent the trampoline some more.
Sure.
So I'm going to run a little animation here. Look at the dent. As the wave of new stars is made, it makes a dent.
Pushes down further.
This has some effects because remember that timeless zone?
Mm-hmm.
We've now dropped part of the trampoline below the timeless zone. But then after all of this happens, God was stretching out the heavens like a tent curtain. So God stretched out the fabric of space, making this nearly flat region rise up. So here's one of 17 verses in Scripture that talks about God stretching out the heavens like a tent curtain.
Yes. Wow.
And so I'm going to watch our cross-section of the trampoline now as God stretches out the heavens, see what happens. The dent in the trampoline gets shallower, it gets pulled up.
Okay, just like the weight comes up off it. And
so if you tightened up the trampoline with something, the ring would not be as deep.
Makes sense, okay?
Okay. So let's go back to our timeless situation. That stretching raises the dent back up above the timeless level. So I'll run the animation here with the timeless level in place. You see that dent, parts of it come up first. I'll run it again. Parts of the dent come up first near here, and then later on where the earth is the last thing to rise above that dent, or above that timeless level. So now, all of this is graphs, and I know a lot of people have problems with graphs. So I'm going to run a simulation just to show you how it would look if you were looking at the universe from God's point of view.
All right.
In cross-section. The point will be that this wave of timelessness followed the wave of new stars. So we're going to start in the center, and there's God making the new stars, but did you notice a wave of blackness behind the new stars? Let's run that again. So right here in the center, God has already dented that trampoline enough to drop the earth into the timeless zone, and it's black in the timeless zone. Nothing is happening there.
All right.
But now God is going to make the wave of stars, new stars, and behind it will follow this black area, this wave of timelessness. Then that black area will rebound from the waters above and shrink back to nothing, and then you'll see a green dot, which is the earth that appears. And so let's just run it again. There's the wave.
There's the
black thing. Now the black thing is shrinking. Now the earth has popped out there. As the stars pop back out behind the wave of timelessness when it's shrinking, their light is following that wave in there.
So there's where the light starts.
Yeah, and if that wave is, the timeless zone is shrinking at the speed of light, then the light follows right behind that timeless zone, that sphere of blackness. And as soon as the earth pops out and the timeless zone disappears, that light is already right there. But all the time the earth is in the timeless zone, there's nothing happening. So no time is ticking at all here on earth.
That's
if
amazing.
you had been here on the night side of the earth, the sky would have been black for a while. And then there would be some instant when suddenly, boom, you see everything there.
Wow.
All the stars, all the galaxies.
During the ordinary days of creation week on Earth, light from distant galaxies traversed billions of light years of space from the edge of the observable universe to the center. God created the cosmos such that on the sixth day of creation, when Adam looked up into the vast depths of the heavens, he could see all the splendor of God's handiwork.
Rather than put your faith in any human theory, you should use this one as an example that God can indeed work out what may seem impossible to us. Even if my particular theory should eventually turn out to be wrong, I know that there is a correct creation model of the cosmos, because observation and Scripture both confirm that God created the universe very recently. For in 6 days the Lord made the heavens and the earth. Exodus 20:11. Distant galaxies look like nearby galaxies. And this is a picture from the Hubble Ultra Deep Field Telescope that is looking way out there. Here's one galaxy that's a little closer to us, and you can see that it looks like a spiral, and all of these little specks on the picture are galaxies of 100 billion stars apiece.
Wow.
We're looking very deep into God's universe here. But the point is that as deep as we look, all of those galaxies look very much like the galaxies that are nearby us. And according to the Big Bang, we should be seeing those galaxies as they're younger and younger, closer and closer to the Big Bang, and they should be much less developed, but they don't. They look just as well developed out there as they do here.
And you're saying the reason they look developed is they were all made on the same day.
They were all made on the same day, and we're seeing them
and the
as
evidence
that
is there for
timeless zone shrank. So this theory says they should look like this.
All right.
The Big Bang says something quite different. There are hundreds of ways one could use science to get an idea of how old the Earth is. 100 at least, maybe 200 methods. And the surprising thing about this is the proportions. 90% give you a young world. 90, most. Most of the evidence. Now you see, other people think that this 10% is all they know about. That's radioisotope dating, carbon-14 dating, light from distant galaxies, and things like that. They've all heard that. That's the evidence that you find cited. But most of the evidence is in the literature, but it isn't tagged. It's in science literature, but it's not tagged as evidence for a young world.
Present physical theories teach that it takes upwards of billions of years for the creation of stars. How do you reconcile that 6,000 years with the formation of the Earth?
Oh, well, the evolutionary theories assume entirely naturalistic processes for the formation of stars. So they bring gases together and have them slowly get together by gravity, and then they have to lose some energy, and then they collapse some more, and they spin around and have to lose some angular momentum, and there's a whole series of processes and several stages along those processes. There's sort of a hand waving. Every evolutionist acknowledges this. They say you could have a protostar, but getting from a protostar to the next stage, we don't know how that happened, et cetera, et cetera. So there's some iffy questions in that imagined naturalistic process. But we don't know that the star is formed by that process. It may simply be that God said, I want a star, here it is, kaboom. That seems to be the way he made everything else in Genesis 1. So the answer is, how do we know how long it actually took the actual stars to form? Helium leakage from radioactive zircons deflates the billions of years. This is the next item, on item 10. At a well in Los Alamos, New Mexico, researchers there recovered some microscopic crystals of zircon. That's zirconium silicate. It's in almost every granite there is. And all of these contain uranium. When zircon forms, it grabs uranium from the surrounding lava, and it rejects lead, so it's an ideal lab for radioisotope studies, or radioactivity studies. So we noticed something about the helium that uranium decay makes. It makes helium as well as lead. You've heard of alpha decay?
Yes, sir.
Yeah, alpha particles are helium nuclei. So when a uranium atom decays, it spits out an alpha particle, and that stops somewhere and grabs 2 electrons and becomes a full-fledged helium atom. And in the size zircons we were looking at, a lot of them would stop, the alpha particles would stop inside the zircon. So I'm going to show you how many helium atoms a uranium atom makes as it decays down to lead. So we'll count them. 1, 2, 3, 4, 5, 6, 7, 8. So if we know how much lead is in a crystal now, we know that that crystal, from experiment, we know that zircons don't like lead, so they will reject it when they're forming. So if you know how many lead atoms are in the crystal, then you know how many helium atoms were deposited. So now that helium leaks. It's known that helium wiggles through a crystal and out into other surroundings. Leaks into the mica that surrounds it. Mica is that flaky, shiny stuff in granite, into the mica, which is called biotite. So the helium leaks out. And usually it leaks pretty fast. So it was surprising to find so much helium still left. Now the question is, how much is left? So here's the depth in miles, 1/2 mile down to 2.5 miles. And the temperature gets hotter and hotter, up to 277 degrees centigrade. That's hotter than your oven gets. And here's the percentage of the helium that we know was deposited that's still in those crystals. 80% in the top, and then it diminishes down to 1/10% at the bottom. 58%, 42. That's a lot of the helium that's left, and this surprised everybody who heard about these results the first time it happened. So we duplicated those results, but this time we wanted to find out how long it would take for the helium to leak out. So now I'm going to do a graph. Now I know a lot of the audience is afraid of graphs. Are you afraid of graphs?
No,
Oh, okay.
I've never been bitten by a graph.
Okay, that's a good attitude. Graphs are our friends. So, but I'll show you, set up the graph. We're going to plot leak rate versus temperature. So along the bottom here is temperature. And I'll just show which way temperature goes. It gets hotter moving this way, and the color gives you a clue. And then the leak rate is vertical, faster and faster as you go up, and this is a tremendously compressed graph, a factor of 1 trillion from top to bottom. We used the data about how much helium was left to make some predictions about how fast the helium would be leaking when we measured it. And so we made predictions based on either 6,000 years here or 1.5 billion years. And of course, the 1.5 billion years would have much lower leakage rates because it has to stay in the zircon much longer. So now I want to show you the data. I want you to see this because this is, it's very surprising. I don't know of any other way to convey the surprise than to show the graph. Okay, here are the percentages. 42, 27, those percentages in the table I showed you before. And that tells us how much helium was lost, and if it was lost in 6,000 years, you would have these diffusion leak rates. Technical name is diffusion, the real name is leak. And if it was slower in 1.5 billion years, then the leak rates would be much lower. So there's a factor of 100,000 difference between these numbers and these numbers. And we predicted this in print in a book that was published in 2000 AD, before we had any measurements made. And then we got some measurements made. We commissioned helium leak rate experiments. This is the borehole, what comes out of the borehole. It's about this big around. Ground up the rock, extracted the zircons, put it in the, we didn't put it in, the experimenter we got put it in. And he was an evolutionist, and we went through an intermediary, so he didn't know he was doing creationist work. And we can compare the measured rates that he got with the predicted rates that we made. So here's the prediction again. And here are the data.
Wow.
And they fell right on that.
Perfect on the line.
Yeah. So anybody who's a techie says, wow. And that's what I said when I first saw it. In fact, I didn't believe it at first. I thought I'd made some mistake. So it really resoundingly verifies the 6,000 year prediction.
That's
and
amazing.
It really rejects the 1.5. So this is the data, the blue dots lining up with the red, and it just completely rejects the other model. I've never seen in my scientific life anything that badly rejected or that
It's
that
such a perfect line.
accepted.
It's amazing.
Yeah, the leak rates are so high that the zircons have to be very young. So we took the measured losses and, in effect, the math is more complicated, divided by the measured leak rates, and we got a date for it. And it's 6,000 years, give or take 2,000.
Plus or minus, yeah.
And that's just amazing to me that we would get this. But yet, the same zircon gives you 1.5 billion years when you use the conventional uranium to lead dating. So that says that God must have speeded up radioactive decay during that period. And a lot of other lines of evidence from the radioisotopes and the Age of the Earth group show the same thing. On the radioisotopes and the Age of the Earth project, I was a co-author with Dr. John Baumgardner and several other people on carbon-14. And so one of the shocking things that most people don't know, and they don't know why it's shocking yet, but is that all fossils have young carbon-14 ages. Now, if you don't know why that's a shocker, I need to explain. This is from standard radiocarbon journals. And things like coal, wood, shell, bone, marble, natural gas, CO2. This is from standard journals that deal with carbon-14, and they all found carbon-14 in them. So they're radioactive. Now, carbon-14 decays pretty fast. It's got a half-life of only 5,700 years, a little less than 6,000 years. So after 1 million years of decay, there would be no carbon-14 atoms left in any fossil. Yet all these fossils are supposed to be older than 2 million years, and a lot of them hundreds of millions of years old. So it was a trade secret of the radiocarbon community for many years that this was happening. But it turns out that it really supports a young world. Conventional age is millions of years. The standard carbon-14 age of all of these is less than 70,000 years, and the average is about 50,000 years. But when you correct the assumption that goes into carbon-14 for what the Genesis flood did to the situation, then the age drops to about 5,000 years.
Now, diamonds play a part in bringing this all to the head as well, don't they?
Yes, that's right. It has to do with the excuse that people use. All the labs assume that somehow modern carbon was getting into the fossils, and that has a lot of carbon-14 in it. So we tested that assumption with the diamonds, like you're mentioning.
So, in other words, the explanation they would give for the carbon that was there is that somehow a new carbon was getting into the old fossils.
Say, fungus got into the coal somehow. And
but
a modern
you found the
fungus
hardest thing you could find where there couldn't be contamination.
Right, diamonds.
And what did the diamonds teach us?
They have young carbon-14 ages too. Nobody had ever measured diamonds.
Wow.
Because you can't contaminate them internally, so they wouldn't expect any carbon-14 to get in from the outside. And the labs don't contaminate them externally. They've taken great precautions not to do that. And we use the world's best carbon-14 lab, and its specialty was small amounts of carbon. And they had 20 years of experience. And these things are from the depths of the earth, which are supposed to be billions of years old. So the conventional age for these diamonds was between 1 and 2 billion years, dated by other methods, other radioactive methods. But the carbon-14 gives you an average of 58,000 years, That's the standard, and we think the assumptions on that are wrong. If they're corrected, we think that it's probably less than 10,000 years. Now, the other side came up with a thought that underground neutrons are somehow generating carbon-14 in the diamonds, and that was a good theory, but the problem is the measured amounts of underground neutrons are too low. But there's a technical book that documents all of our results. It's technical. I should emphasize technical a lot.
So for people who really have a background in science and really want to say, is this evidence valid, and really look into what you're studying, I think the carbon-14 is probably pushing some buttons from some people who want to say, how can they be saying that? And there is a book that gives all the scientific validation of your work.
And it's an excellently done book.
It really is.
Dr. Snelling was one of the editors, and we had a bunch of different expertises brought together on it. It's really worth it if you're a technical person. Now, for the other people in the audience who are not techies, there's a layman's book, Thousands Not Billions. And this was written by Dr. Don Young, who is also on the team. He's a physicist, but he's also a very good popular science writer. And that's available on creation.com and other creationist websites.
And this would be understandable to the layman who has an interest, but perhaps not as deep a background in the material.
Right. Don will go through all the background. So.
And you can get that with a DVD as well, which I think is really exciting.
There's a DVD that has the same name and several others.
Egypt is already in our 13th dynastic period, which is 4,100 years prior to Abraham.
Well, I guess the bottom line is that those dates are pretty contested. And there's an excellent set of articles at creation.com in their journal called the Journal of Creation. And just in the last couple of years, there have been some really good articles on Egyptian chronology. And they point to some major errors that have been made by secular scholars in putting together the Egyptian chronology. So those dates that you see in history books attached to pharaohs are highly questionable. And it's still a matter of great debate, not only among creationists, but among secular scholars, just how to correlate the Egyptian chronology with the biblical chronology.
So let's look at some of this. Where are you going to get your evidence, sir?
I'm going to get it from an internet article that I wrote back in June 2005 at the Institute for Creation Research called Evidence for a Young World. And it's got publication and internet references on the back pages. And you find it on icr.org. And I'm going to go through the 14 items of evidence, not all of them, but most of them, that are in here, and you can get more information from that brochure.
I'm sure many of our folks will want to go to icr.org and follow up on that. So I'm going to ask you to go up to our board and to present some of those key points of evidence for a young Earth to us, Doctor.
The first item in the articles is that galaxies wind themselves up too fast. They're made up of stars, and each individual star likes to rotate around the galaxy, and around the center of the galaxy, stars go very fast. They go very fast there, but way out on the edge, they go slowly, just like the planets in our solar system.
And what do you mean when you say they wind up too fast?
Well, these spiral arms are made up of individual stars, and the outer ones are going around slowly, and the inner ones are going around very fast. So this spiral structure will wind itself up, just like a clock spring.
And so over a period of billions of years, if there was such a thing, it's pulling itself in and becoming tighter.
Yes. All the nearby galaxies, including our own, are supposed to be 10 billion years old for the age of our nearby galaxies like this one, Andromeda. But the winding up occurs so fast that even if you had started with a straight bar of stars rotating at the speeds we now observe, it would only take 0.3 of a billion years to wind up to this state. Now, we don't know at what state God started the galaxies, so we don't really know their age, but they can't be much more than this old by just a straightforward view.
So they hint towards the Earth being much younger than the billions and billions we always hear, or to the galaxies being much younger than
Now, I should
billions
say
and
that
billions.
the other side has a theory. They've had a lot of theories and scrapped a lot, but the current one hasn't been scrapped yet, but it's in deep trouble because it doesn't explain detailed structure of galaxies very well. It's sort of a hand-waving sort of theory right now. It's not in good shape.
Now, while you're talking about galaxies, there's something about magnetic fields.
Oh yes, this is recent news that distant galaxy magnetic fields are young. See, they once thought that very distant galaxies would only be partly formed and only partly wound up, and they found out that that the magnetic fields in those galaxies follow those spiral arms. So this is the letter to nature: strong magnetic fields in normal galaxies, and then I'm going to translate, at great distances.
Okay.
And they weren't expecting that. So I've drawn in the lines of force in yellow there. See these yellow lines? Those are, if you took a compass needle and worked your way around the galaxy with a great deal of patience and a lot of spaceships, you would find that they follow the spiral arms. And that goes against their theory of how spiral arms might preserve themselves for billions of years, and it goes against their theories for this to occur at very great distances. So they're in deep trouble with galaxy magnetic fields and other things.
So again, magnetic fields seem to take us to less than 0.3 of a billion years.
Right. It's it's a maximum possible, and it's a lot less than the 10 billion years that the Big Bang Theory requires. The Earth's magnetic field is something people don't think about very much, but everyone's had a compass at one time or another, and the Earth's magnetic field is what makes that compass needle point north.
Right.
And the point of this is that the Earth's magnetic field is losing energy too fast to be very old. Now, what do I mean by energy? Well, the source of the Earth's magnetic field is an electric current that goes around westward in the Earth's metallic molten core. And it's an electric conductor, but the electric conductor has resistance, and that wears down the current year by year. So it's a bit like a flywheel, slowly slowing down due to friction. And that current is the source of energy in the Earth's magnetic field, and it's losing that energy much too fast. According to the latest numbers for about the last 30 years, the Earth's magnetic field, all of it, is losing about half of its energy every 1,400 years. In other words, you add up all the parts of the different parts of the Earth's magnetic field, every 1,400 years it's losing half its energy. So it couldn't have been losing half its energy for too long. But there's another factor, and that is during the Genesis flood, it lost energy faster than this rate during magnetic reversals. The Earth's magnetic field actually turned itself around from north to south and north to south every couple of days during the Genesis flood, according to the evidence that we have. And the only theory for this, for such rapid reversals, is a creationist one. It's mine. And that says that we would lose energy even faster. So you add all these things up and you work yourself back to the largest electric current that we could have in the Earth's core without having too many problems, and you get a maximum age of about 20,000 years. Again, if you account for this loss during the Genesis flood of energy, then that age could easily be 6,000 years.
So we're down to thousands, not billions.
Exactly.
Again.
Now, the evolutionists do have a theory. It's, again, sort of a hand-waving theory that says that something in the Earth's core would try to maintain this current over billions of years. But again, that theory doesn't work very well.
There's not really any evidence for it.
No. Now, in support of this young Earth point of view, Mercury's magnetic field looks like it's young. Now, here's a plot of time along the bottom. This is the year. This is 4000 BC, and here's today. And magnetic moment, that's just a measure of how strong the source of a magnetic field is. And this is a very compressed scale, and you don't need to know the numbers. But I have a theory for the created value of the Earth's magnetic field. And then we had, in 1975, the first of these little dots. That was 1975. There was a measurement by a satellite called Mariner 10 of Mercury's magnetic field, and it was already down to here. So my theory would say that the field decayed steadily on a straight line on this kind of graph. Very rapid decay. It's 3 times faster than the Earth's field is decaying. In another couple of decades after 1975, my theory said, we should be able to detect a decrease of that field. And we found it. Here's the Mariner 1975 number, and then Messenger, the Messenger spacecraft, in 2008 measured a lower magnetic field, very significantly lower. And it's within the bounds of my prediction, or it might even be a little lower. But that's very hard for the other side to explain.
That's fascinating. And so both the magnetic field of the Earth and of Mercury have indicated that they just can't be that old. Is that right?
Right. And the same theory works just as well in other parts of the solar system, too. So we think we've got a pretty good explanation of magnetic fields in the solar system, how they started, what happened to them, and how they got to where they are today. And that theory has made predictions.
All right, while we're still in outer space, let's talk about comets.
Comets crumble too quickly. Now, a comet is what Fred Whipple called a dirty snowball. But this is something that creationists have known about for some time, so I won't spend a lot of time on it. But these dirty snowballs, when they swoop by the sun, lose that material that you see sweeping off away from them, being swept off by particles and light photons from the sun, and that material doesn't all come back.
Most of a comet is mostly chunks of ice and dirt.
Yeah, and then when it gets
well
close to the sun, it bubbles and hisses and emits gas and dust, and that streams out in a tail behind the comet and never comes back.
They burn out, don't they?
Yeah, so every time around the sun, a comet will lose maybe 5% of its material. So if they come around pretty often, they couldn't have been around very long. They're supposed to be 5 billion years old, the age of our solar system. But it looks like they could only be in the solar system less than 100,000 years at most, 10,000 years on the average. So the other side has a theory. It's called the Oort cloud. There's supposed to be a cloud of these dirty snowballs way out beyond the boundary, and it's a spherical cloud. And that cloud is supposed to feed dirty snowballs into something called the Kuiper belt. In the Kuiper belt, we have seen some large asteroid-sized chunks, but not comet-sized chunks of ice, but not very many. And it wouldn't be enough to explain things all by itself. It has to be fed by the Oort cloud. The thing is, nobody's ever seen the Oort cloud of our solar system.
In fact, don't we even have evolutionary scientists saying that they can't find an Oort cloud?
Yes, I knew one back at Louisiana State University who he wasn't a creationist, but he was very skeptical about the Oort cloud theory.
And without an Oort cloud, then comets have to be young.
Yes. There's not enough star explosion smoke, I call it. The official name is supernova remnants. Here's an example of one, the Crab Nebula. That's dust and gas from a star that exploded. And you can see these supernova remnants they should last about 1 million years, 1 million years. So astronomers figure that we should see about, at the rate that supernovas happen, we should see about 3,000 in our part of our galaxy. And the question is, do we see that much? And the answer is no. We only see about 200. So that implies, very roughly 7,000 to 14,000 years worth, and those numbers change a little. So it's not the million years worth that we should be seeing. Oh, I forgot to mention, yes, there's an update. Last year, Creation Research Society conference in 2014, a fellow named Keith Davies, an astronomer, has pointed out that The same thing is true for our nearest neighbor in the southern hemisphere, small dwarf galaxies called the Magellanic Clouds. They should be able to see those supernova remnants in the Magellanic Clouds, and they don't see nearly as much. They see only thousands of years, not a million years worth.
Now we're going to leave outer space and we're going to go down in the ocean.
Seafloor mud accumulates too fast. Geoscientists have figured out that we have about 20 billion tons of mud entering the ocean every year. And then we have some that gets out. And the total amount of mud in the ocean, if you took all of this mud and spread it all over the whole ocean, it would be about 400 yards thick. And then to get out this mud, we have plate tectonic subduction. That's the only way known to get much out. These plates of gigantic thick slabs of rock are sliding under the continents slowly at about the same speed that your fingernail grows. Not very fast. But if it dragged all of this 400 meters of mud underneath, then it would get rid of about 1 billion tons per year. Maybe 2 billion if you wanted to be real optimistic. But that leaves 18 or 19 billion tons unaccounted for. So we have, let's say, 18 or more billion tons per year, just accumulating year after year. And it wouldn't take too long, from a geoscientist's point of view, to get this amount of mud.
So if you measure the mud that was there, how many years would we come up with?
At most, 12 million years.
Yeah.
Now, the thing is, we have this thing called the Genesis flood to reckon with. And so in 1 year, you could easily dump almost all of that 400 yards of mud in a short time between 4,000 and 5,000 years ago. This process of mud entering the ocean is supposed to have been going on for 3 billion, billion with a B, years, not 12 million. So,
and if that were true, there would be a whole lot more mud by now.
That's exactly right. The oceans would be choked with mud.
Almost, yeah, without oceans. All right. That's an incredible argument. And then also, while we're in the ocean, not only the mud, but the salt is a problem to the old Earth people.
That's exactly right. The sea isn't salty enough to suit the taste of an evolutionist. Dr. Steve Austin and I wrote a paper on this. We tabulated, and not only we, but geoscientists in general for 80 years have been tabulating this. There's about 450 million tons per year of sodium going into the ocean.
It isn't really being dumped out of a salt shaker.
No.
Yeah.
It's being dumped by those same rivers that dumped mud.
Okay.
And other sources. There's other ways that sodium can get into the ocean. The mid-ocean, mid-sea springs, for example.
Okay.
But getting out of the ocean, geoscientists have only been able to find at most 120 million tons instead of 450. Getting out, like if you smelled salt spray at the beach, that's some sodium getting out of the ocean, being blown out as crystals. So that sets a limit on how old the ocean can be also. Now the maximum possible age, if it started with no salt to begin with, and if the rates were the best possible rates that the evolutionists conjecture, then the maximum age would be 62 million years. The Genesis flood could easily account for most of the sodium that's in the ocean today. Mitochondrial Eve was supposed to be 200,000 years old, but as they actually started at mutation rates to figure out how long ago this mother of all living things was, they got as low as 6,000 years, and that was actually published.
6,000 years.
So mitochondrial Eve is pretty young. DNA in amber. DNA, that's a model of a DNA molecule right there. DNA is supposed to decay within 10,000 years. The experts on DNA say even if you preserve it in the best possible conditions, it will fall apart on its own within 10,000 years or less. And yet, in amber, that's supposed to be 135 million years old, they can reconstruct the DNA of insects. Interesting, lots of things. So that's less than 10,000. Permian bacteria. Permian era was supposed to be 250 million years ago, and yet they have revived bacteria from formations that are supposed to be that old. Again, the DNA, their own DNA should have fallen apart by that or been destroyed by environmental radiation. And Neanderthals, they've dated Neanderthals. By the way, they're ordinary humans, just another branch of the human race. And they got some blood that was allegedly 40,000 years, and they reconstructed large parts of his DNA. And so Neanderthals were probably here a lot less.
Less than 10,000
Less than
years
10,000. Dino blood cells. They found that blood cells from a T-Rex a few years ago. You may have read about that. Supposed to be 70 million years old, actually less than 10,000. Now, this issue of the Creation Research Society Quarterly, it's a quarterly scientific journal, has a whole issue devoted to this stuff. It's called the iDino Project. We looked at a Triceratops horn and extracted soft tissue from that horn and published in a secular microscopy journal. So the guy who did that was fired by his university for publishing something pointing to a young dino. But lots of things in that issue. Among the other things is carbon-14 dates on dinosaur bones, and I'll talk about that. But lots and lots of stuff about preserved tissue, preserved flesh in fossils. Now, things that old, if you had an uncooked chicken leg bone, you put it in your refrigerator, and you left it there for 70 million years, you think any of the flesh of the chicken bone would be left. So that's the problem that the people who are doing, like the lady who was one of the contributors to the dino red blood cells, the T-Rex blood cells, she's been accused of being a clandestine creationist. She vehemently denies it, says she's a Christian, but she's a theistic evolutionist Christian and believes in the millions of years. So she and others have been working on ways they could preserve those things for 70 million years. And thus far, they don't really have a good working theory. But this issue discusses her theory and some of the other theories and the evidence against it. So where you get this issue, the Creation Research Society Quarterly, soft tissues in fossils, half-life, the half-life of that soft tissue is thousands of years.
My name is Lyndon. In your lecture, you mentioned the existence of dinosaurs, T-Rex and Tyrannosaurus Rex and so on. What I wanted to ask you, though, is would I be able to find any reference at all in the Bible to dinosaurs? Well, not necessarily by that name, but in your estimation, is there any reference at all in the Bible to that kind of animal, that kind of creature?
Oh, in the Bible for a dino? I'm sure a lot of you already know this, but go to Job, chapters 38 and 39. And I think it's chapter 38. It describes a very large creature named Behemoth who lives in a swamp, and he apparently is the largest of all God's creatures, and he's a veggie eater, and it describes him as his bones are like bronze and they're strong, and it's a big thing, and he swings his tail like a cedar. Have you seen that? They used to think that brontosauruses couldn't fit that. Actually, brontosaurus is the old name. It's an apatosaurus now. But they used to think that those creatures had such big tails that they had to drag them behind them. But they didn't find any tail drag marks in the brontosaurus or apatosaurus tracks or any of the other large dinos. So they finally decided that the tail was stiff. And so he bends his tail like a cedar. There's some stiffness to it, and they didn't let it drag. And the whole description fits an Apatosaurus, there's a really large version of one of those types called Seismosaurus by nickname. He's really big. And God said it was the biggest of his creation. And then in the next chapter, there's a description of Leviathan, who is a seagoing dinosaur with scales, and his teeth are like doors, and around his teeth there is terror, and he's really big, and no one can capture him. He's that dangerous. That's Leviathan. But he's a swimming, seagoing dinosaur, and he fits a lot of these, they're not officially called dinosaurs, but they're seagoing reptiles that everyone looking at them would say, that's a dino, like a plesiosaurus. So Leviathan fits that description pretty good. This is real simple, not enough Stone Age graves. Now the evolutionary point of view, this is time along the bottom here, and this is the evolutionary view of the total population of the human race. About 1 million people it would be limited at by hunting and gathering. You just can't get more than so much food per acre by hunting and gathering. And then at the end of that period of limited food, then suddenly some bright cave guy is supposed to have discovered farming. I don't know why it would take him nearly 200,000 years, but anyhow, then the population took off. But if you ask yourself how many people were alive during that 200,000 years and were buried, you get about 8 billion people. That's 2 billion more than are on the earth now. So you should be able to go to your backyard and find a Neanderthal or Cro-Magnon grave, and you can't.
I haven't found any.
So it's much more consistent with a short Stone Age after Babel, which was after the flood, for a few hundred years in most places. So only thousands of those graves exist, and it's consistent with a short time, not a long. Now, this is one that's obvious. Written history is too short. If you just plot the number of published documents that we can find, now the published documents are in the billions. Around the time of Christ, the number that were around couldn't be more than millions. And back around the time of Abraham, we're down to thousands, like Egyptian hieroglyphics. And somewhere we get back to Noah's diary, and that period of time is small. It's only 5,000 years. And so, you know, what about the other 200,000 years? What were we doing then? We were supposed to be pretty smart.
Wouldn't they say that before that time man couldn't write?
Yes, but that's kind of hard to imagine because Neanderthal and Cro-Magnon men actually seem to have been smarter than us to survive in an ice age. Most of us would probably not survive, so they were smarter than us. And they used cave paintings and inscribed on bone the phases of the moon. Why not use the same skills to write history?
Is Big Bang science wrong about the age of the Earth?
Creation.com has much more evidence of that sort. They have this article called 101 Evidences for a Young Age of the Earth. It's like a longer version of this with 101 evidences, several paragraphs per evidence, and fully documented from the scientific literature and the internet and so on. So you go to creation.com, and then you just plug in 101 evidences into their search engine, and this article will come up. So we're not talking about just a teeny tiny little bit of evidence. This is actually most of the evidence on the age of the Earth that exists.
Really, are you trying to make the observations fit the preconceived conclusions?
Am I trying to date? Are
you trying to make the evidence fit your conclusion, really?
No. For example, that helium date that I got, I was as surprised as anyone when it came out close to 7,000 or 6,000 years. It was 5,700 and something years was the average for all the crystals that we had looked at. And the spread on it was 1,999 years. I remember that. So was as surprised as any of that. I didn't make that data, and it's in the rate book. The data is in that chapter of the rate book. So same thing for the Earth's magnetic field. It points to 6,000 years, but I'm not trying to make it fit 6,000 years. That's the way the data comes out.
We have Earth's rotation around the sun is a year. We have a moon, but we have the moon rotating around the Earth. We have a day, and the day is a spinning of the Earth, a rotation of the Earth. And then, but we also have a week. And where does the week come from?
From God. It apparently is just because God set things up in 7 periods, and people apparently in all cultures all over the world just kind of picked that up. There are actually about 4 or 5 different reasonable physics explanations for what might cause the redshifts, and the expansion is only one of them.
Okay. So if the universe is that a position that you take? Is that I think that it is, although I'm investigating some alternatives. So.